In this video, we'll prep for the properties of logarithms by first looking at the properties of exponentials and see how they relate to the properties of logarithms. In your college algebra course, you'll see how to actually apply the properties of logarithms. So the first thing is to remember the product rule for exponents, which says that a to the m times a to the n is equal to a to the m plus n. So that's saying if you multiply two exponentials with the same base, then you add their exponents. So let's look at an example of the rule for the product rule for exponents, and let's show with that example how it relates to the rule for the product rule for logarithms. So let's do it with an actual numbers for the base, and you'll see that it really doesn't matter because we'll never actually use that specific value. So let's for the example, we have 2 to the m times 2 to the n. Then from that product rule, we know that's equal to 2 to the m plus n. Let's let a equal to that 2 to the m and b equal to 2 to the n. So a is equal to the first factor of that product on the left hand side, and b is equal to the second factor. So by the rule for or the definition of the logarithm, that this tells us that if a equals to 2 to the m, then the log base 2 of a is equal to m, and log base 2b equals to n. And that's just using the the definition of the logarithms. So by this, we know that if we have log base 2 of a times b, so if we're taking the log of the product of a times b, then that's equal, well, we know a times b is that 2 to the m times 2 to the n. So what is the power we need to raise 2 to get that product? Well, from that statement from the product rule for exponents, that the power we need to raise 2 to get this 2 to the m times 2 to the n, we got to raise it to the m plus n. And then just substituting back in what we said, what m was equal to. M is equal to the log base 2 of a plus log base 2 of b for n. So the product rule for logarithms is that if you have the log of the product, that's equal to the sum of the logs. Okay? And that's again showing how it relates to the product rule for exponents. Now notice I chose the base of 2. Did that matter? Not at all. And looking at the quotient rule for exponents, if you remember, the quotient rule for exponents tells us that a to the m divided by a to the n is equal to a to the m minus n. So let's do what we did before. Let's do for an example. Hey, let's say if our base is 3. So we know that 3 to the m over 3 to the n is equal to 3 to the m minus n by the quotient rule for exponents. Okay, so again, let's let a equal to this 3 to the m, and let's let b equal to the 3 to the n. Then again, by the definition of the logarithm, this tells us that the log base 3 of a is equal to m, and log base 3 of b equals to n. So looking at the log base 3 of a over b, so what if we have the log of a quotient? So remember, a over b, that was equal to this 3 to the m over 3 to the n. So this log base 3 of a over b is the same thing as asking, what do we have to raise 3 to get this 3 to the m over 3 to the n, which is the same thing as what do we have to raise 3 to get 3 to the m minus n. Well, we got to raise 3 to the m minus n to get 3 to the m minus n. So that log base 3 of a over b is equal to m minus n, which, as we were just saying, that's equal to the log base 3 of a minus log base 3 of b. So this is saying that the log of the quotient is equal to the difference of the logs. And again, that's showing how it relates to the quotient rule for logarithms. And again, the base of that logarithm could have been anything, or any positive number. Now, if you remember, one of the power rules for exponents is that if you have a to the m raised to the n, then you multiply the exponent, so that's equal to a to the m times n. So again, what we're going to do, well, let's keep the base 3. So if we had 3 to the m raised to the n, that's equal to the 3 to the m times n. So let's let a equal to this 3 to the m. So by the definition of the logarithm, again, this tells us that log base 3 of a, what do we have to raise 3 to get a? Well, we got to raise it to the m. So that's equal to m. Okay. So what if we had log base 3 of a raised to the n? What if what was inside the logarithm was raised to an exponent? So that's what we have here. This is log base 3 of a raised to the n is saying, what do we have to raise 3 to get a to the n, which again, a is this 3 to the m. So that's asking, what do we have to raise 3 to get 3 to the m raised to the n, which is same thing as 3 to the m times n. So we got to raise it to the m times n power. And then m is equal to this log base 3 of a, then times n. And usually we like to put the number in front. So we would have that as n times log base 3 of a. Now this will be a very useful property of logarithms, that if you have an exponent inside the logarithm, you can move that to the front of the logarithm and it'll be that exponent times that logarithm. And like I said, that's going to be a very useful property for logarithms that you'll actually see in your college algebra class. But again, all I wanted to show here is how do these properties of logarithms relate to the properties of exponentials.